Let me share my screen. This is where we left off. So yeah, so here I'm gonna have this 2 times that 3. I'm gonna have 6 root what 2, right? Minus.
Right.
Mm-hmm.
That is the step name.
Hmm?
Why don't we write that to the power of 5 as an exponential form?
Okay, let's go back and do that. It's no problem. So if that's what you want us to do, no worries. Let's do that. So I'm gonna have 2 to exponent of 5, all to exponent of what? 1 over 2, right? My so everything is still fine. With regards to this one, everything is fine, right?
Yes, sir.
Okay, minus 2 to exponent of what? 5 over 2, right? And then here I have a
Yes.
6 times 2 to exponent of what? 1 over 2, minus 2 to exponent of what? 5 over 2. So now what do? I see that I have a 2 here, I have a 2 there. So I can take out 2 to the exponent of something as a highest common factor. But I have to look, that something has to be the smallest exponent, right? So let me check. What is 5 over 2? 5 over 2 is equal to 2.5. And 1 over 2 is equal to 0.5. So therefore, I have to take out 2 to the exponent of 1 over 2 as a highest common factor. So check now. I'm going to have 2 to the exponent 1 over 2 into 6 minus. So from here, I'm gonna have now what? I'm gonna have to minus that 1 over 2 from that 5 over 2 because I'm taking out 2 to the exponent of 1 over 2 as a highest common factor, right? So that's whereby now it's going to be 5 over 2, 5 over 2 minus 1 over 2, which is just gonna give me 2 to the exponent of what? 2, right? And then here, 2 to the exponent of 1 over 2 is just square root of what? 2. And then here I just have 6 minus 4, which is the same as 6 is going to be 2 root what? 2. So I think that's the final answer because it's in set form. Remember, leaving your final answer in set means that you must have a root of something as an answer, a root attached to something. Are you guys okay?
Yes, sir.
Do you see why the exponent here is 2 and no longer 5 over 2?
Yes.
Guys, guys, you guys do not respond.
Oh, say,
Um,
What is your question, sir?
where is 6 coming from? Say, I missed that part.
Okay, the 6 is coming from this 2 times that 3. Because remember, whenever I multiply, the order of multiplication doesn't matter. So this 2 times root 2 times 3 is the same as 2 times 3 times root 2. And I know when I multiply these two things, it's going to be 6 root 2. Are you okay?
Yes, sir.
Okay.
Thank you.
So with regards
uh,
to, uh-huh,
where did the 5 go?
which 5? The 5 over 2.
Yes.
Here I had an exponent of 5 over 2, right? Right?
Yes.
Okay. So let me do this. I see that possibly, probably for, let me, let me erase from this step so that you guys can understand me taking out the highest common factor, right? Let me go now.
Yes.
So I have 6 times 2 to exponent of what? 1 over 2 minus 2 to exponent of what? 5 over 2, right? And I said 1 over 2 is the smallest exponent. So I'm going to have to take out 2 to exponent of 1 over 2 as the highest common factor. So let me rewrite. So I'm going to have 2 to exponent of 1 over 2 minus. Check. Here I'm going to have 5 over 2 can be rewritten as what? 2 to the exponent of what? 1 over 2 times what? So for me to get 5 over 2, what number can I add to 1 over 2 so that I can get what 5 over 2? So I'm gonna have 2 to the exponent of what, in other words here? What number can I add to 1 over 2 so that I can get a 5 over 2? That's simple maths, guys. What number can I add to 1 over 2 so that I can get 5 over 2? So this means that whatever that number is just gonna be 5 over 2 minus 1 over 2, which is just gonna be 4 over 2. So here's just the exponent of 4 over 2, because if in case I add 1 over 2 and 4 over 2, I get 5 over 2. Are you guys okay? I rewrote this, in other words. I rewrote it. So this means that 2 to the exponent of 5 over 2 can be written as 2 to the exponent of 1 over 2 times 2 to the exponent of what? 4 over 2. According to that law of in case I multiply powers of the same base, I just add the exponents and then they're going to give me 5 over 2. Are you guys okay?
Yes, sir.
Fine. So let's move on. Let's
Okay.
do. Mm-hmm.
Okay, let me ask you this in a simple way. Ne? So just because you took 2, 1 over 2 as the highest common, did you minus that from 5 over 2 there as the exponent or what?
No, I didn't exactly minus in this case. I just separated 5 over 2 into 1 over 2 and 4 over 2 because even in case I add these two things, I still get 5 over 2. I rewrote this, in other words.
So if I minus, is it correct?
Huh?
If I minus, is it correct?
Which minus, ma'am?
You okay? I'm saying if I minus the high one, if I minus 1 over 2 from 5 over 2, is it still correct?
Yeah, because I even here so that I could get that exponent that I wanted here. That's what I did. I said, okay, because I know I have to have 2 to exponent of 1 over 2 times 2 to exponent of, I don't know what is it. Like, I said I didn't know what is going to be here, right? So for you to find out whatever is going to be here, let's say, so you want a number that you can add to 1 over 2. Let's say what number, I don't know what, but I know that when I add those two, I must get 5 over 2. So that's why I'm going to have x is equal to 5 over 2 minus 1 over 2. So that I will know that this x is just equal to 4 over 2. Therefore, now I know here I must put 4 over 2. Are you okay?
Yes.
So I'm just rewriting this. I'm rewriting this. Are you guys okay?
Yes, sir.
Guys, all of you. Guys?
Yes, sir.
Yes,
Okay.
sir.
So I see that I can take out this as a highest common factor. Let me take it out. So I'm going to have 2 to the exponent of 1 over 2 into 6 minus 2 to the exponent of what? 4 over 2. And then here I know that this 2 to the exponent is just root 2. And this, I don't have to stress I can just put it into the calculator. So I'm going to have 6 minus 2 to the exponent 4 over 2. It just gives me 2. So my answer is going to be 2 root 2. Are you okay?
Yes, sir.
Okay. So that was it. I can make another a recording for you guys, but it won't be a lesson. I'll just make another recording for you guys where I'm solving other problems so that you guys can get an understanding of how we do these kind of problems. Is that okay with you guys? I'll upload it to YouTube as well and send the link of it into the group, but I won't do that video as a lesson. I'll just do it separately on my own time, right?
Yes.
I'm gonna do that video for you guys. So now let's continue with probably the work of the day. Let's say, let me add a page. What we are doing today is called Ra rationalizing. Oh, the denominator. So that's what we are doing today. Guys, yeah. So that's actually the business, the main business of today, actually. So today we are looking at the concept of what? Uh, let me do this. Draw. Yeah. So we are rationalizing the what? The denominator. So the principle of rationalizing the denominator is to remove the sets, the irrational numbers in the denominator. So have you guys, so I'm gonna give you guys a quick introduction to this. I know. Have you seen how, let's go back to your trigonometry really quick, right? But I'm not going too deep into it. But do you remember that from grade 10, you know a triangle that's like this? Sorry, let me erase and draw a beautiful one for you guys, because you guys are beautiful learners, right? You have 90 degrees. Here you have 45 degrees, 45 degrees, right? And then the triangle has one here, and then here square root of what? Two. Do you remember this triangle? It's a special triangle. You remember this special triangle from grade 10?
Yes, sir.
So remember, whenever you wanted, let's say, the sine of 45 degrees. Remember what is sine? Sine is just equal to opposite over hypotenuse. Do you remember that? So let's look at what is opposite to 45 degrees. It's a value of what? Of 1. So we're gonna have 1 over square root, the hypotenuse is square root of 2. So the value of, so from the value that you would get is this, right? That's what you'd get, right? But please now punch into your, so now use your calculator now. Use calculator. And from the calculator, give me what is the value of sine of 45 degrees. And make sure that your calculator is not in radians. Not in radians. Make sure that it does not have an R there at the top. It must not have an R. It only must have a D here at the top. So what is the value of sine 45 from your Casio or your Sharp calculator, whatever?
Square root 2 over 2.
Square root of 2 over 2. Wow.
Yes, sir.
Wow. So I'm surprised. Wow. Why is it that if I do it via a triangle, so via a triangle, I get sine of 45 degrees to be equal to 1 over square root of 2. But via a calculator, I get sine of 45 degrees to be square root of 2 over 2. Wow. But I know mathematically, since this is sine of 45 and here's also, I must get the same value on both sides. So now check. For the one that you got via a triangle, you got what? 1 over square root of 2, right? And then for the calculator, you got square root of 2 over 2. So these two things must be what? Equal. Because it's sine of 45 and it's sine of 45 degrees there. So they must be equal, right? But they look, when looking at them, when looking by looks, they look like two different values. Are you guys still on the same page with me? They look like two different things. Are you guys okay?
Yes.
Yes, sir.
So now the question that we may possibly ask, how are they equal but they look the same? Look, here underneath I have square root of 2, but here I have a 2. There at the top, here at the top I have 1, but there I have a square root of 2. So the question that we can ask is, how did 1 over root 2 change to square root of 2 over 2? When we do it by a diagram, we get this, but in a calculator, we get this. So how did this change to that? Right? So that's the question that you may be asking yourselves right now. Right?
Mhm.
So now my answer to, so this is a question that you guys have, but my answer is just gonna be what? How do we get it? How do we change it? We are gonna simply what? Rationalize the denominator. So today we are gonna learn how did this turn into that. So hence we are dealing with the topic of rationalizing the denominator. Are you guys okay?
Yes, sir.
Yes, sir.
Okay. So now let's see how this concept of rationalizing the denominator works. So let's say I wanna prove actually that what? 1 over square root of 2 is actually equal to root 2 over 2. Right? So let me take what is on my left hand side. I have 1 over square root of 2. Right? Right?
Yes, sir.
And I want it to
Yes,
turn
sir.
into that. So I know that 1 over square root of 2, it's the same as if in case I say 1 over square root of 2 multiply by what? By 1. Right? Are you guys okay?
Yes, sir.
Check. I continue. What if I say 1 over square root of 2? But then this 1, I rewrite it as what? Multiply by what? Square root of 2 over square root of 2. This is still a 1, right?
Yes, sir.
This is still
Yes.
a 1, right? But check now.
Yes, sir.
The top, the top values multiple. So I'm gonna have 1 times square root of 2 is just gonna give me square root of 2. And then at the bottom I have square root of 2 times square root of 2. So at the top I have square root of 2. But at the bottom, if you choose you put what is on the bottom into your calculator, you're just gonna get what? A value of how much? 2.
2.
So do you
Oh,
see?
yes, sir.
So now look, square root of 2, we know it's a what? It's an irrational
Number.
number, right? But we know that 2 is just a what? 2 is what? Rational, right? So
Yes, sir.
look,
Yes, sir.
previously we had a what? We had 1 over square root of 2, right? So it had an irrational denominator, right? The denominator was irrational. But now we have square root of 2 over 2. And then 2 is what? Rational. So we rationalized the what? The denominator from. So here we had an irrational denominator, right? But here we have a what? A rational denominator. So therefore we rationalized it. We rationalized it. We changed it from being what? Irrational to being what? Rational. So we changed the denominator from being square root of 2 to being a what? A 2. So we changed it from being an irrational value to being a what? A rational value. Are you guys with me?
Yes, sir.
Yes, sir.
Okay. So now, you now understand the process of rationalizing the denominator, right?
Yes, sir.
Yes.
So this means that if in case you want to rationalize if in case I give you 1 over square root of 3, square root of 3. So you know in order to rationalize this, you're going to multiply this thing by what? Square root of 3 over what? 3, right?
Mm-hmm.
Yes.
And then it's going to give you square root of 3 over what? 3. So that you've rationalized this denominator of square root of 3. Are you guys okay?
Yes,
Yes,
sir.
sir.
So let
So what if like he left it at 1 instead of you saying square root of 3 over square root of 3? He said multiplied by 1. It's fine, right?
so you want us to say 1 over square root of 3 times 1.
Yes, sir. Is it right? Like even if we don't include
But how
part
do I know
B.
that you actually got to square root of 3 over 3 if in case you just have a 1 here?
Okay, you have a point.
Because the purpose of this thing is a 1. This thing it's equal to 1. But I'm rewriting my 1 in a way that can allow me to rationalize the denominator. Hence,
Oh, okay.
I didn't leave it at 1. I didn't leave it here. I changed this 1 to that.
Okay.
That's the entire purpose of rationalizing the denominator.
Okay, sir.
Are we all on the same page?
Yes,
Uh,
sir.
Yes, sir.
Can we move to examples?
Yes, sir.
Okay. So I'm going to go to the textbook, grab a few examples. Yeah. So, yeah, let me just do A and B, right? So let's do a bit of examples. So a bit of examples that we can have. It's just that, right? So we have to rationalize the denominator for what? For A. So A, we are given 6 over square root of 3. So we know that this is just going to be equal to what? 6 over square root of 3. Square root of 3 multiply by what, guys? Guys, what am I multiplying by? Learners, you are quiet.
By 1, sir.
Yes, what is that 1? I'm going straight to the answer. What must I write here? Guys? Okay. So I'm going to multiply by square root of 3 over square root of 3. Was that hard?
No, sir.
This is a 1, right? So you must tell me what your value of 1 is. So let's continue. So I'm going to have what? The top value is multiplication. So I'm going to have 6 square root of 3 all over what? Square root of 3 times square root of 3 from your calculator is just going to give you a 3. So this changed to that. Are you guys okay?
Yes,
Guys,
Yes, sir.
Sir.
yes, sir.
now letter B. What is letter B? It's 8 all over cube root of 2. I know that this cube root of 2 is irrational. Cube root of 2 is an irrational number from your calculator. It's going to give you decimals, so it's irrational. So you want to rationalize it. So guys, I'm going to write 8 over cube root of 2 times what?
Cube root of 2 over cube root over 2.
You guys are now smart. So I'm going to have 8 times cube root of what? 2 all over the cube root of 2 times the cube root of 2 is just going to give you what? A value of 2. Are you guys with me?
Yes, sir.
And then now, it's going to give me, what am I going to get? It's just going to be, no, 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 no. No, it's not going to work like that, guys. No, because check, now I have 2 tracks, cube root of 2 is just equal to what? It's equal to, check, it's equal to 2 to the extent of what? 1 over 3, right?
Yes.
Are you guys okay?
Yes, sir.
Yeah.
And we want this thing to turn into a what? A value of what? 2, right?
Yes, sir.
Right? But then here, I have an exponent of 1 over 3. So how many 1 over 3s must I add to get 1? I must add 3 1 over, so I'm going to have 2 times 1 over 3 times 2 to the exponent of 1 over 3. If in case I add these 3 1 over 3s, I'm going to end up getting 2 to the exponent of 1. Are you guys okay? Because I'll be adding these exponents. Do you guys see that?
Yes, sir.
So now you guys are correct that we are multiplying by 1. But now this means that here, because it's no longer a square root, so here we are going to have to change this to what? Check now. So that the thing at the bottom can turn into a 2. This means that, remember this is the 1 over 3 itself, right? And I already have a 1 over 3 here. And I multiplied by how many other? 2 1 over 3s, right? Are you guys okay? So
Yes,
what
sir.
is 2 to the exponent of 1 over 3 times 2 to the exponent of 1 over 3? It's going to give me how much? 2 to the exponent of what? 2 over 3, right? Which is the same as cube root of 2 to the exponent of what? 2, right? So here, to rationalize my denominator, I can just say multiply by what? By 2 to the exponent of what? 2 over 3 all over 2 to the exponent of what? 2 over 3. Because now I'm going to have 8 times 2 to the exponent of what? 2 over 3. And then at the bottom, I'm going to have 2 to the exponent of 1 over 3 times this 2 to the exponent of what? 2 over 3. And then now, what is at the top? 8 can be expressed as 2 to the exponent of what? 3 times, here it's 2 over 3. Sorry. So it can be expressed as 2 to the exponent of 2 over 3 here, all over. I can add the bottom exponents. It's going to be 1 over 3 plus 2 over 3, which is just equal to what? To 1, right? And then here at the top, I'm just going to have 3 plus 2 over 3. Going to give me 11 over 3. So 2 to the exponent of 11 over 3 over 2. So this 2 to the exponent of 11 can just be written as cube root of 2 to the exponent of 11 all over 2. Are you guys okay? So the denominator is now rational. So whenever you have nth roots, like now you now had cube root of 2, right? You now had cube root of 2. It's not the same as square root of 2. So for square root of 2, in order for you to get a 2, you have to multiply by another square root of what? 2. for me to get a what? A 2. But for me to get a 2 out of a, a cube root of what? Of a cube root of 2, I have to multiply this thing by how many? I have to multiply it by how many times? I have to multiply it what? How many times? 3 times. You guys see that? In case I have
Yes,
them.
sir.
So this means that I already have this on one's there. So I have to multiply it by only 2 others at the bottom and at the what? At the top. So this means that you could have just rewritten this as what? As 8 over cube root of 2 being equal to 8 over cube root of 2 times what? The other 2, which is cube root of 3, cube root of 2 times cube root of 2 all over cube root of 2 times cube root of 2. There's still a 1 because these things are just going to cancel each other out, right? And then I just multiply everything that's on the top. So I'm going to have 8 times 2 to the exponent of 1 over 3 times 2 to the exponent of what? 1 over 3 all over. At the bottom, I'm going to have 2 to the exponent of 1 over 3 times 2 to the exponent of 1 over 3 times 2 to the exponent of 1 over 3. And I know this 8 can be written as 2 to the exponent of what? 3. So at the top, 2 to the exponent 1 over 3 times 2 to the exponent of 1 over 3 all over 2 to the exponent of what? 1 over 3 times 2 to the exponent 1 over 3 times 2 to the exponent of 1 over 3. Then I have the same base at the top, so I'll add the exponents. What is 3? 3 plus 1 over 3 plus 1 over 3. It's 11 over 3. So I have 2 to the exponent of what? 11 over 3 all over. What is at the bottom? 1 over 3 plus 1 over 3 plus 1 over 3. It's going to give me 1. So I have 2 to the exponent of 1, which is a rational denominator. So I can rewrite this as what? 2 to the exponent of 11 over 3 all over 2. But I know that 2 to the exponent of 11 over 3. I just look at the denominator. The denominator is going to tell me which root am I taking. So I'm taking the cube root of what? Of 2 to the exponent of what? 11. So I'm going to have cube root of 2 to the exponent of 11 all over 2. It's the same as me saying that I have 2 to the exponent of 1 over 2. I see the denominator, so I know that I'm going to have the square root now, but of what? 2 to the exponent of what? 1. You understand me turning back and forth? You guys understand?
Yes, sir.
Okay.
No, sir.
You don't understand?
Yes, like I'm lost.
From where?
You from the beginning, it's kind of complicated.
Okay. Uh, Let me do this. I'll just erase the whole. Guys, just for future reference, if in case you don't understand anything from the beginning, stop me from the beginning. Don't stop me at the end. Right? You
Yes,
see,
sir.
we are left with
Yes, sir.
6 minutes. So uh let me erase everything. You don't understand this problem, right? Letter B.
Yes.
But letter A you understood because we were dealing with square roots there.
Yes.
You understood that one.
Yes, sir.
Okay.
Yes.
So let me do this now. Before I start solving this second problem, I want to compare the letter A and letter B. I'm going to compare the two problems so that you guys can see the difference. Yo.
It was too much saying. Oh,
Remember that I was giving you guys a second approach. I was not. It wasn't all one step. So you had 8 over cube root of what? 2, right? That's what you are given
yes.
for letter B. And look at letter A. Letter A, you are given what? 6 over square root of 3. 6 over square root of 3. Check. For this 3 to be rational, how many, uh, like, I know that this is 3 to exponent of 1 over 2, right? So I just need to multiply it by a 3 to exponent of what? 1 over 2 for it to turn to a 3 to exponent of what? Of 1, right? So I multiply 2 of them. So the denominator tells me how many must I multiply? I'm multiplying how many? 2, right? I'm multiplying
Yes,
how
sir.
many? 2, right? And then this is what's going to happen on the denominator when I'm multiplying, right? But I already have 1. And where do I have that 1? I have it there, right? Right?
Yes,
You
sir.
guys get me? So that's why I'm gonna have 6 square root of 3 times now only 1 square root of 3 over square root of 3. So I'm gonna only have 1 at the top and 1 at the bottom. Because I only need to multiply. I only need 2 and I already have 1. So I only need to multiply by what? By another 1. Another square root of 3 over 3. Another square root of 3 on the denominator and at the numerator. You guys understand? I already have this one, so this means I need to multiply by the what? By the other one. And this other one, I need to have it at the top and at the bottom. Is that okay? I already have this one there. There it is. I just need to introduce another one. Are you guys okay?
Yes,
Guys?
sir.
Yes.
So where this is just gonna be 6 square root of 3 over square root of 3. Fine. Fine. Are we fine?
Yes, sir.
Yeah.
Okay. So now let me go to letter B now. This letter B has a denominator of cube root of 2, which is the same as what? 2 to exponent of what? 1 over 3. So this 3 now tells me I have to multiply how many times? 3 values, right? Because here I had a
Yes.
2, told me I need to multiply how many? 2 values, right? So for me to get a 1, I have to have 2 to exponent 1 over 3 times 2 to exponent 1 over 3 times 2 to exponent 1 over 3. Then it's going to give me a 2 to exponent of what? 1. Are we okay? Because when I say 1 over 3 plus 1 over 3 plus 1, it's going to give me 1. It's going to give me this 1. When I add, yeah, because that 1 is just 1 over 3 plus 1 over 3 plus 1 over 3. Put that into your calculator, I'm going to get a value of 1. Are we all on the same page?
Yes, sir.
Fine. So I'm
Yes.
multiplying 3 times. But check, I already have one of them. I already have this. Where? I already have it there, the denominator. So this means I only need how many additional? I need to only multiply 2 other ones at the top and at the what? At the bottom. So that's where now my problem is going to change to becoming what? I'm going to have 8 over cube root of 2 times what? I'm going to multiply by 2 other ones, right? So I'm multiplying by cube root of 2
Yes.
times cube root of what? 2 all over cube root of 2 times cube root of 2. And there's also a 1 because this can cancel this, cancel that, cancel that, and it's going to give me a 1, right? It's still a value of 1. This whole thing is still equal to what? To 1.